The foundations of modern physics are being shaken by a phenomenon so strange it borders on the supernatural. At the heart of this mystery is the double-slit experiment, a test that suggests the world around us might only become real at the exact moment we choose to look at it. While classical physics suggests the universe is a stable, predictable place, the subatomic world operates by a terrifyingly different set of rules. The debate began over 3 centuries ago as a clash between scientific titans. Christian Huygens argued that light behaved like a wave, while Isaac Newton insisted it was composed of discrete particles. For over 100 years, Newton's prestige kept the particle theory dominant until Thomas Young's famous experiment in the early 19th century. By shining light through 2 narrow slits, Young observed an interference pattern, a series of zebra-like stripes, proving that light traveled in waves. However, the dawn of quantum mechanics in the 20th century turned this victory into a paradox. When scientists repeated the experiment by firing single photons one at a time, the interference pattern remained. It appeared as though a single photon could travel through both slits simultaneously, interfering with itself like a ghost. Even more disturbing was the discovery that adding a detector to watch which slit the photon entered caused the wave pattern to vanish instantly, leaving only 2 simple lines. The act of observation alone forced the light to abandon its wave-like nature and behave as a solid particle. This observer effect suggests that consciousness or measurement dictates physical reality. In the late 20th century, physicist John Wheeler took this further with the delayed choice experiment. He proved that even if a scientist decides to observe a photon after it has already passed through the slits, the photon retroactively changes its past behavior. This defies the law of causality, implying that the future can determine the past. Recent breakthroughs in 2023 have pushed these boundaries even further. Researchers at Imperial College London recreated the experiment within the dimension of time, while teams in China demonstrated these effects at the incredibly small Fermi scale. These findings suggest that the strange laws of the quantum world are not just limited to space but are woven into the fabric of time itself. We are left with a chilling conclusion: the macroscopic world we inhabit is built from microscopic particles that exist only as clouds of probability until they are measured. This raises the haunting possibility that the universe is a grand rendering similar to a video game, where reality only loads when a player is watching. As science continues to probe the boundary between the observer and the observed, we may find that the world we see is far more fragile and mysterious than we ever dared to imagine.